Time trying to record this. Hopefully now it's working. So, uh, struggling a bit with the my non-professional YouTube video content not creator setup. You know what I'm saying? So, long story short, what I was trying to say here is that we solved a remove elements yesterday, which is an array problem, and we tackled the brute force and an optimal solution for that problem. And today we're going to be tackling remove duplicate elements, which has a few different constraints here. Basically, reading the problem, I was reading the problem. Is my hopefully it's the last time I read the problem now. It says that is an increasing order, non-decreasing order, which is very frustrating and annoying when they say non-decreasing order, which means increasing order. So we have uniqueness, so each element should be unique on the return, on the output. And the first unique elements are k, and they should be returned in order, and they should be at the beginning of the array, and what happens after k doesn't matter. Basically, that's the requirement here. If you read here, that's basically what it says. And then we have the input and output, which I started working here. And as of now, I would like to think if I mean like I know I could use sets to solve this problem due to sets nature, which we know that returns only unique objects and values for that specific set. Uh, but what we want here is think on a most raw solution here. For example, what would I do in this case? Okay, amateur solution here. What would I do? Let me open this board here and zoom in. Maybe it helps. Let me reduce this. Right, alright. Cool. Now what we have here. We could start iterating the array, and if we can, um, for example, have a counter, or we could have something that would say, hey, this number already exists. That could be an object. That could be a set. That could be anything. But anyways, I would need to check if the element already exists at some point. And a way to do this is knowing that the array is ordered. What we could do is instead of using set, I could just check if, uh, for example, I start iterating and I see, hey, I'm in this number here, and if there's one more occurrence of this number, let's say that, for example, I plus 1 is the same, what we could do is iterate until it's not the same. Or we could create another pointer that would go into k, where it's different. And then we would have the window, which was what we learned previously. And then we could start uh, basically shifting back the array here. All the items in the array uh, back to its position, and that would happen for each of the array items basically. Um, that means very clearly that in this case, for example, if we were iterating and the first item is I, so I would have nums I plus 1 is the same as nums y, or k would be I plus 1. K would be 1, you know, it would be 1, okay? If k is 1 and I is 0, and then we could start iterating basically, and I would ask, for example, if k is same as y, same as I, and then knowing that if k is equal y, I would increment k until it's different, basically. So what I would do is I will be here, and then I'll start creating another loop here until k is different from I. And then what I would do, I would start iterating uh, back here where um, yeah, I will leave k there actually, and then I'll start iterating I, and then when I is different from k again, we would like swap those guys here. So that will be something like this. Yeah. Um, and then k would be here. And then we could ask again, uh, is is k different? And then I would go again, back again. Okay. And when I is different k, we would do the same, right? Be 2 plus ba ba, then it will be 3 ba, and k plus plus da da da, then 4. So that's a way that we could do this, right? That will be on. Let's see. There's something I'm missing here, which is a basic. Um, I mean, like you could always think like you know forward, but I think when coming to terms and array processment, knowing the nature of the computational effort and how arrays actually work, usually it's better if we could count, work with, uh, not thinking onwards but thinking backwards, because that's actually how it is expected to, I mean, like these are the items that are the end of the array, and they are, you know, these cost less to change than this by any means. What it means that is that working with arrays, we always like to, you know, be forward, you know, be most likely here. So instead of doing this and comparing, we could always ask if the last item was unique, for example. Although I think this could work as well. I want to try the solution, to be honest. Let me see if let equals 0. Uh, let I equals 0. Let's see. Let j equal k equal 1. Let let I equals 0. I don't know if that will work, but yeah, in less lesser num length plus plus. And then what I'm thinking here is basically um, if I equal k nums I equals nums k, what you're doing, uh, you're not doing anything. Um, mm, okay, yeah, and you're not doing anything, and when you're gonna skip this, what's happening here? So k is still the same place. So if it's not equal, which will be the else, uh, what we're going to do here is say that k is equal y, uh, nums k equals nums I, and then say k plus plus, right, bro? And then what's going to happen? Next iteration be 1, and the next iteration I'm going to get on 2. Well, hopefully this works. Um, if nums y equal nums k, if nums y nums I different nums k, you do this. So this should be here. It's nums I different nums k. So that'll be 0, 0. Then we'll come here and it'll be 1. And that's it. Otherwise, you just increment I, right? And then we can return k. So that works. No. Why? My solution was wrong, and I was thinking here, and I think that I've found the reason why. So let's start again. Basically, now I found if we start, obviously, if we start at this item 1, what we need to check is only if the item before the the, the actual index is equal, because what we know is that in a sorted array, the we what could gives us a constant is the fact that the element can't be duplicated in a specific order. That means if O plus one or O minus one could be used to define if we have a duplicate or not. And in that case, if we start at k and y here, k and I here, what would happen is I could check is k um, different from k minus 1. It is, so I could update k and I and go forward, and that again, uh, and that again. I don't think that's the right array here, but yeah, that's the right array. Go back here. Okay. If I would start here, I now could start arguing that is K uh, is it K the same as K minus one? If so, I don't touch K and I keep iterating until I find something that uh, if I nums I different nums K minus one nums K equal nums I, right? And then I can say K plus plus. So that means you come here, uh, 1, K, then this is K. Then we start iterating back again. Is it different from K minus 1? No, no, no. And until it is again. And say, hey, it is different. Okay, then K plus plus, and then it's 2. Then that makes sense because uh, the nature of the I index will always count I plus 1, and the nature of K will count K minus 1. And that makes sense now. Um, yep, same thing again. Okay, that should do. So I think if we do something like this, so if K is equal 1, let I equal 1 minus length, blah, blah, we would say if nums I different nums K minus 1, let's see now. Yeah, that's it. Okay, good. Nice one. I won't even tackle a brute force solution for this one because it was very obvious that the solution uh, for me is simple now. I don't even would think in a brute force solution because I can't think of it now.